Okay, so I'm one of those folks that Katerina talked about, the 621% increase from 2017. So I'm one of those. We are Privado, and we are building privacy enhancement technologies, transparency enhancement technologies, and I represent this privacy engineering, tech landscape that is coming up. So what we'll be discussing today is transparency and accountability, and I'll give you an industrial perspective on how we build these tools and how they can be actually operationalized, and towards the end, a small wish list that I have. So this is how data looks initially. On the left side, we see code in its inception stage, and at this time there is no data. But eventually, as you start collecting, the code becomes, websites, mobile apps, and bots. The collection increases, and then we have more data transferred from these collecting services, which are just collecting this data and sending it to more processing, which is actually providing a service, taking that data and making some decisions, or using it for analytics. So at this time, the spread is increasing. We can see that the spread is increasing towards the right. And then we don't know what these analytics and services are doing. They might be sharing it, to third party. You log into Netflix or to Facebook, and your data is just not there with these two organizations. It goes multiple places also. We saw this complex, architecture that Elias had put in. That's actually very true, and I've seen this in industry. It's too difficult to understand where your data will go. So all the text that I used to see for privacy policies, etc., it's very difficult to even understand what happens with that data. So eventually it gets stored in databases, data lakes, and at that time it's too difficult. So this is what's going on. At the early stage, we have no data, just it's in the inception stage. We have an intention to create or move data, which is in the code. And then there's a little bit data, more data, and then enormous data. And what's happening is that in real world, this is a real example of Shopizer, code, and you can see that a developer wrote a collected username and they logged it, log.info username. So what happens is when you run this in a real environment, you'll have users interacting with this Shopizer. Shopizer is just a web app for e-commerce. So essentially customers are going to interact with this. And what's going to happen is at each second, imagine you have a service running Shopizer and you'll have 500 people inputting their data. And then it goes onto a cloud logger, which you have no idea about where it is running. And then eventually gets scraped from that logger and stored in 20 different databases. So you see the spread now, this is exactly how it happens. At early stage, there was one line that defined the intention of what should be done with the data. We are taking it and logging it. And eventually what happens is it goes to 20 databases nobody has an idea about. And so it's easy. We can start looking towards the left, look at the intention. What was the intention of, what was supposed to be with the data? This would be early, easy, and proactive. These are all the things that current regulations also talk about. You need to be proactive, instead of being reactive about privacy. That's the way to go, I would say. And then the other approaches that we see in the industry is, very late in stage. So, you have the database and there's a tool like DSAR, data subject access request. And then you would go inside these databases, try to figure out where all the data is, and then you either remove it, move it, or whatever the request was. And then, so essentially, like, this is where we see modern privacy tools operating. They are looking at this border of data getting shared or getting stored and trying to understand what to do with it. But we believe that it's very easy to go on the left-hand side. So if you try to look at the data when it's already produced, it's, huge, enormous, spread everywhere. This is what it actually feels like. It's kind of like sweeping the ocean. There's an ocean of data everywhere and you're trying to sweep it with a broom. That's not what we want to do. This is a small graph I created of what's happening with these tools these days. On the y-axis is maturity of the solution. You can see the big players there, OneTrust, BigID, etc. And on the right is depth of engineering integration. So you see that the depth of engineering integration is more easy as we go towards the code, because that's where the developers are. They are sitting down, they are thinking what to do with the data, they translate it into code. So the engineering integration becomes very easy as we move towards the right, because the data is not even there yet. It's at the inception stage, so we can control it much more better. These approaches we usually see are also static in nature. So, and static is more proactive. Even before things get released, you would know, where, what's supposed to happen to the data. And some of the tools are there who are, approaching towards that. The other layers that we see very common these days is the border of APIs and databases, intercepting at that layer. And there are tools like DataGrail, Transcend, Fidelis, who have a language already defined, a configuration-based language, and they can define what to do with it. They directly intercept into data moving through the APIs. You have developed an app, you decided to use Slack, or you decided to use Salesforce or any of these third-party services, they would try to intercept the data going there and understand what's happening here. And towards the code side, the approach is more really understanding what the developer intended to do. When the developer wants to interact with Salesforce or Slack, they will write some code, so you can even intercept it before it even runs. So that's kind of like the approach here. An ideal case which I have is this cone that I've created where the capabilities overlap, so that you can completely observe infra, DB, APIs, code, towards the system. And that's where, privacy engineering tools are slowly approaching towards. So let's look at the impact on transparency and accountability here. So this is a document from the Department of Justice, in Canada. And this document specifically talks about accountability and transparency and its effects on privacy. And regulations are now being drawn up. So this is more kind of like a discussion document to push towards these regulations now. And in that, clearly, we see the benefits of a strong privacy management program are clear. Integrating privacy management programs into the Privacy Act could. And two of the things that I've highlighted are support a transition away from reactive oversight model to a more efficient proactive one, and encourage holistic data governance by networking or linking a wide range of policies and governance tools together through Privacy Management Program Hub. So an example they also state is the algorithmic impact assessment tool. This is really interesting because it's something that you have to do these days where if you're using AI technologies and you're working with the government, you would have to do an algorithmic impact assessment, pretty tongue twisting here. So where you have to specify what you do with the data, how it was collected, and what's the impact on this automated decision that the tool will take. But you know what? This actually is just a spreadsheet. So an engineering mind is not going to work exactly like that. They're going to look at this big document and they will start moving towards the right. So they will see that we need to keep users informed wherever in our service we are collecting data. And on the accountability side, they will say, okay, need to know who is doing what with the customer data. And we can keep on moving. And for transparency, they will start saying identify points in our apps where private data is collected, and then minimize collection information in a non-legalese exact purpose and provable steps to safeguard data. Inform the user about these things. Same with accountability, identify points in all apps where private data is collected, who decided this collection, what tech did they use, and then establish a clear, provable data ownership chain. So these are the requirements that engineering folks are going to think about. And in my mind, this is how it starts looking at it. So it starts right from the code. We have code, and then we can scan that code. And as it gets developed and gets deployed, data goes in multiple places. We discussed this. But what we can do when we have TNA probably logged is kind of like an internal TNA log that could be created. So you can say on the first step itself, when Ankita creates code to log username using Apache Logger, the scanner just tells us that, okay, she created this code which is logging username and it's using Apache Logger. And then the scan now keeps on looking at the whole system and starts adding more information towards this. Username is being sent to a logging service. It's running in US East. The release gets pushed. When a new release is done, it gets pushed. analytics team has access to logging. This is inferred from infrastructure as code. And a lot of these deployments and everything that you see these days is just code. Nobody is sitting down and pushing buttons. It's all defined where this specific part of the whole application is supposed to go. So this is what our intention would be, have customer UX, privacy management center, then you can say the customer can see you are in version 0.01 of the Foo app, beginning 2023, Foo began accessing your username. So these are very dynamic, privacy identification, of what's happening to your data and what you want to do with it.
So you can understand complete architectures, and scanning at this layer definitely can be helpful. It can also be proactive because when the code is actually running, a lot of context on how to fix privacy issues is lost. You need to go back and understand who input data, who input code which is handling data, and then try to understand it. But this approach of scanning very early on helps you become proactive. At the same time, you have a big accountability chain that you can maintain. So a developer introduce something in the software, and during the very early on in the software development lifecycle, you can actually understand each action that the developer took. So you can have these TNA events, transparency and accountability events, which tell you what was added and when it was added. At the same time, it can help in driving the transparency UX that we discussed also. So, all these internal TNA events that you were seeing, they can actually become part of a big privacy control center, and you can, really understand deeply what happened at exact point of the time. So all this embedding has to be done from all angles possible. So all angles as in like introducing privacy very early on in the software development lifecycle directly at the code layers, then carrying it forward as the code gets deployed. So, all these things can complement each other, but being proactive is one of the goals that has always been there, and our approach would help you solve that.
That ends my presentation.
All right, great. Thank you.